All right, getting started with part two of our first Mastercam 5-axis session. Just a quick recap. We talked very briefly about some NCI formatting, the fact that there's no rotation commands that are output in the NCI toolpath data. We've generally got two types of toolpaths. We have a plane-based toolpath, which can include 3-axis output which can include arc output. And we have a 5-axis toolpath, which is strictly vector-based. And a vector position is just a tool tip point combined with a UVW vector tail described in 3D space relative to your WCS. So the vectors are essentially the input to the post processor, which is going to be what resolves those moves and gives you actual 3D output. So as a quick example, if I just take this curve 5-axis toolpath, I've got a UMC post processor, and I'll output the G code. So that series of what we would consider NCI G code 11 moves, right? This is some different input, right? It's a different time that I generated it, but the format's going to be exactly the same. Every one of those vectors is an XYZ and a UVW position that the post processor then interprets and it spits out in your G code. So it's not till we get down here we actually see some B-axis rotation. It goes from B-axis 0 to roughly 9 degrees, almost 30 degrees, and then back, and you get a bunch of XYZ moves. Make sure. Sorry, guys, I started the recording. I did not do the screen share. You were sharing. Okay, so let me back up there. So we've got a toolpath as input. We're going to post process. We're going to output and edit both the NC and the NCI file just for that path only. And what we've got, tile horizontal. Come on. It's going to make me close it. Okay, so what I'll do then, up in the same, there we go. And tile vertical should work now. Okay, so part of what was happening, part of what happens in the posting process, if you're outputting both the NCI file and the NC file, and you've got edit turned on so that it actually loads the file in your editor, it will pause in between the NCI file output and the NC file output, and it will force you to close the editor. So I've closed the NCI, I got the NC file, and then I reposted the NCI without the NC so that it would keep both of them open. And as you can see, the input is going to look way different from the output. But if we scroll down to where the actual start of the file is, we're going to see some similarities. So that XY position, also contained up here on this first line, that XY position is what's generating this here. And it's not till we get down to this move. So we're looking for an X of 4.77. So we're just going to search 4.7721. And so this is actually that first vector. We go view, higher horizontal. And what you can see on that line is that the vector is going to slightly change. It's that change in vector that's then going to get resolved to create this rotary angle output to actually rotate the machine. And because we're using dynamic work offset and tool center point control, the coordinates are actually a really close match to what the vectors actually look like. So if we were doing a different post-processor, especially a post-processor that was without some of the dynamic codes, that's going to influence what that output looks like. Part of the reason I'm bringing this up is just to understand there are a lot of different potential inputs into generating a 5-axis toolpath, and there are a lot of things that can influence how that code looks and how it functions. Now, fortunately, we're dealing mainly with Haas machines, at least, for the foreseeable future, and based on, the way that Federal operates as a division, which is great. Other machines have different technology and different complexities when it comes to producing 5-axis G code and what you can actually achieve. So there are some limitations to, for example, tool center point control and dynamic work offset. So one of the things that's important to understand, dynamic work offset can only correct for error in one rotary axis. And in the case of a UMC machine, that is a C-axis rotation error. So we can, for example, set up a UMC 750 5-axis, put a part in a vise at the center of the table that's not precisely dialed in, let's say, and we can measure what the rotary correction on the C-axis would be. Say it's negative, I'm going to make up a number, 1.28 degrees. And so we could put a negative 1.28 or vice versa. If it was a negative, we could put a positive value in the work offset table for the C-axis. And dynamic work offset will be able to work with that offset in the C-axis and compensate for it. This is not true for the B-axis. So it's always very important when we first kind of come up to the machine and start looking at it. UMC 750 has what's called a tool change offset for the B, which means we can go through a process of leveling out and setting the B-axis 0 position. And it's important that we do that and we ensure that the table is truly flat and level at B-axis 0, and that, as we build up our work holding stack, that if, for example, we load a self-centering 5-axis vise on top of the table. We want to verify that those jaw faces are parallel at 0 to the b-axis, because even if the table is zeroed, if the stack up of our work holding is not precisely zeroed, we may need to re-zero the tool change offset on the b-axis to ensure it's perfectly parallel, right? So that everything works. And that's really the goal, right? Is, hey, I want to make 5-axis easy. Well, that requires that we make sure that our setup is correct before we start. One sec, everybody. Okay. Let's get back into this curve 5-axis toolpath a little bit. And, there are lots of different 5-axis toolpaths. I don't have any expectation that we'll get through more than just the very beginning today. But the nice thing is we can repeat these sessions as often as necessary to cover all the different stuff. And to be frank, I want you guys to explore and discover new things and teach me. I've learned all this stuff over the years by asking other people questions and digging and reading and trying and experimenting, and I'm not done. Not by a long shot, right? It happens every day where I'll find or they will develop some new tool in the software, and my goal is to understand it as deeply as I can, and then to help communicate that to other people so they can learn it in their own way, right? And just give it the best chance we can of having as close to a full understanding. Like, that's my goal, and that's why we're always in learning mode at Philips. So I'll get off my soapbox. Let's get back to the task at hand, right? So cut pattern. Again, we have the combination of the 3D curve we're cutting. Let's get back in here, highlight the chain so we can see the chain, right? We're cutting some kind of 3D curve. The compensation type and direction, which we generally want to use computer. We don't use wear or reverse wear or control. Why? Because they don't affect anything. You're not going to get any change in output of the G code, no matter which of these you pick. So just stick with computer. It's easy. And pay attention to the radial offset. Make sure it either matches what you want or you're setting it appropriately. Now, what's different from contour versus this? No stock to leave. So be aware of that. If you want to leave stock, you need to leave it in the radial offset. If you want to take off more than the tool, you got to take it off in the radial offset. But there's no plus or minus stock to leave, okay? You do that by controlling the radial offset. Tool axis control. There are a couple of different types. So lines, surface, plane, from point to point, chain. Well, surface is just that. You want it to be normal to some type of surface. I mean, the surface that we have, this flat surface, would just give us a vertical tool, much like a 3-axis toolpath. Well, let's do something different. We'll just save this. Sec. Is it still going here? It is. Okay. Okay, so different types of tool axis control, right? Surface, plane, from point to point chain. Quick example for the surface. So what I'm going to do is just go look at this from the front view. I'm going to set a Z depth of, say, 3 inches positive, and I'm going to set my 2D, 3D to 2D here. And I'm going to go in and create a 3-point arc. Oh, yeah, I know. That's fine. I hate it when it's like that. Okay, let's do that. Let's do that. Oh, hold on. Got to change my plane. Oh, so got to talk about something. In Mastercam planes, this is the planes pane, P-A-N-E, not P-A-I-N, although one could argue that they're one and the same sometimes. There are some settings in here you guys should be aware of. First one I'm going to do, because I like it, I'm going to turn on contrast rows. It just alternates white and gray, kind of helps you line things up. There's an option called follow rules. So that's this little menu here. There is a setting in here that absolutely drives me crazy. C-plane follows G-view. When this is enabled, you'll see a little check mark next to it, and it's enabled by default. When that's turned on, if I change, for example, to the front view, did you notice what happened here? If I change to the right side plane, you see how that moves? Doesn't do it for isometric, but it'll do it for like the sides of a cube. This little selection here is one of the worst selections in Mastercam. I like to turn it off by default so that my plane doesn't change unless I tell Mastercam I want my plane to change. So I might not have set it correctly. That's okay. I'm going to set it correctly in this case. So front is selected. I'm going to look at this in the front view. We're still in front. I'm going to do a 3-point arc. Take that arc and I'm going to project it. I'm going to copy it to, say, -6. Let's make sure that's far enough. It is. Great. I'm going to go to surfaces, and I'm going to loft a surface, and I'm going to use those 2 chains. And we get a surface. I'll say OK, and I want it reversed, so I'm going to go to change the normal, and I'll click on it. By the way, how can I tell what side of surface is the normal? Change this to a green. So there's a setting in Mastercam under the View menu, the View ribbon, called Backside. Now, when Backside is not enabled, the top and bottom of every surface are going to have the same color. Whatever color the surface itself is set to, it's going to appear as if the surface has the same color on both sides. And I believe that's true, yeah, even in wireframe display mode. So I like to turn on backside, and when I do that, this olive green color, not quite olive drab, is the backside surface color. So that way you can instantly visually see which side on the surface is positive and which side is the backside. So the surface normal is always the positive side of the surface. One other thing that's true So I've got a couple levels turned on, 4 and 5. I want to examine this surface here and this surface here without everything else in the way. I could move them to a different level. I could turn off the existing level, but I'm going to use a function called screen hide. And screen hide is available on the home ribbon under hide and unhide, but it's much more common to do Alt E on the keyboard. Alt E is the hide command. So I can select entities and press Alt E to temporarily hide everything else. It's a toggle. So I can then hold down Alt and press E on the keyboard again to bring everything back. So really quickly, I can select what I want to keep, Alt E, I can work with it, and then I can Alt E again to bring everything back. All right, so I'm going to hide those two. Now, I'm going to do Alt S on the keyboard. And what Alt S gives me is the surfaces or whatever is displayed in wireframe. So I've got this surface here, I've got this surface here. But do you notice how in wireframe display it's relatively hard or difficult to see the curvature of those surfaces? We can change that display. So for a surface, it's an attribute. So I'm going to select both of those surfaces and I'll right click. So I've got them selected. I'm going to right click, and this little toolbar up at the top here is called the attributes toolbar or attributes bar. So there's an option in here is multiple attributes on the selected entities. So a lot of these are single entity attributes, right? I can change point style. I can change line style. I can change line width. So as an example of just kind of one attribute that's built in here, I've got these selected. I'm going to change to a thin line style display, and I exit the menu. If I select these again, right click, and I do a set all, that's going to bring up this dialog box. And one of the things I have access to set is what they call surface density. The surface density does not affect the physical characteristics of the surface besides the density of the lines that are displayed in wireframe display mode. It is a visual only setting. So just to know, it doesn't affect the accuracy of the surface or of the tool path in any way. If I click on this little question mark, you're going to get the little help menu. So they talk about it. Oh, the parameters. They don't even tell us, do they? Huh, that's pretty weak. So surface density, it's like it's a nothing thing, right? They don't have any information on it. It's a scale from 1 to 15. Okay, so 15 being the most dense. I think it's actually 0 to 15. 0 being the least dense. Why? Because it was probably like a 16 or whatever bit number, 8-bit number that only had those value capabilities way back when they first designed it. So I'm going to change it to 15. Should let me do it. What if they've actually changed the surface density? Let's see if I... Or if it's just broken. So let's grab that. So I knew the input was 0 to 15. Okay, so how about 14? Let's change the color as well. Let's give it another thing to change at the same time. Wow, that's broken. Because
does it require a tab or enter key? Some of these dialogues are kind of weird. They don't seem to commit.
Usually it shouldn't. So if this is 2020, set all, because it's got a checkbox. It's got a checkbox, right? Yeah, 2020 it works fine. So I can go and I can change my set all, and I can go surface density 15. This is like my standard workflow. And if I do a set all and set it back to 0, okay. I mean, that's what it's supposed to do. It's supposed to change the density of the line display. Oh, maybe I just needed to change the zoom. So I was just changing the display. I didn't zoom in and out. As soon as I zoomed in and out, it updated. So that's probably what's up. Okay, so
I think I've seen some screen color issues in 2024.
Yeah. So if I change this to 10 and I zoom, well, let's just say it's not as, oh, yeah. So if I zoom out and zoom kind of back in far enough and get it to refresh internally, it does seem to be changing. But that's not right. So just so you all know, when you try this at home, yeah, do it and then zoom in and out far enough and it should change the density. Okay, that's just a quick aside. That took a lot more time than I would have liked. That's okay. Moving on. I'm going to go back to surfaces. I'm going to change that one. Correct way. Okay. Save it. And I like that density because now when I unshade, I can much more clearly see. But this is funky. Look at this, bro. If I look at this in shaded view, you can clearly see this is the top side of the surface. I click on change surface normal. You can see the normal's pointing up the right direction, right? You agree with me?
Yep.
This is the bottom. If I unshade, the unshaded display of the normals is reversed from the shaded display.
What happens if you grab that speed menu and clear colors? Does it have the same problem, or does that rectify it?
Now, it's not a zoom thing either. It's just plain old backwards. So in unshaded, it's showing me a reverse normal. Because if I go to surfaces, set, it's not even giving me the arrow. But if I'm shaded and I go to set, I don't know. I'm having some funkiness. Now, I've run into all kinds of things, right? It could be a result of us just broadcasting this on Teams. Sometimes that can be funky. So anyway, again, moving on. So I got this toolpath. Right now, it's controlled by lines. So I'm controlling where and when it tilts. Boom, boom, boom. Well, that's all well and good. Now, let me make sure so that this works right. I'm just going to extend the edge surfaces just to be sure. Okay, so I've got this surface. I just created a random 3-point arc underneath. If I go into this toolpath and I change my tool axis control method from lines to surface, now I can select the surface. I'll grab that surface underneath there. I'm using this surface normal against this geometry chain to control how the tool is pointed. When I switch my tool axis control to surface, it enables a new control down here. I think that was, yeah. So before, this was grayed out. It wasn't even taken into consideration. But now that it's on a surface, it says, how am I going to project? Am I going to project normal to a plane or normal to a surface? And normal to a surface is typically what we do. And in this case, I have to increase my maximum distance. Default is 1/10. And I'm going to say, no, no, no. Go ahead and project up to 2 inches. I'm good with that. So now what we generate instead, keep in mind what my input was. My input was a chain. And yet now I am using a surface underneath to control the angle of the toolpath. And that surface is only curved in one direction, so I would only expect the toolpath vectors themselves to curve in one direction and not to also rotate. Unless my surface underneath was different. So as a fun test, right? Okay, well, what if we wanted it to rotate in 2 directions? Let's just rotate the surface 22 degrees. No. I want to be in the top view. So I've got to go to planes, top. I'm going to select that surface, rotate, move it, and okay. Now we should get right side view. I've got tilt to those vector lines. Let me turn on the advanced toolpath display because it looks a little better. Okay, so definitely tilted in that direction. How about in the front direction? Oh, I'm tilted in the front too. So now I'm tilting through multiple directions as I drive this toolpath because I'm driving a surface underneath, and at every position along my chain, I'm projecting down a point and then using the normal direction of the surface at that point to control the orientation of my vector. Now, would I use that rotated surface underneath there like I just showed in the example? No. But just kind of pointing out some methods, some different methods of tool control. Save that. So another method of tool axis control that's available here is plane. So even though we've oriented this in the top, I can change this to plane, and now I can select which plane that's normal to. There's no real option to just kind of rotate the plane while you're in the middle of the toolpath. But say, I wanted to, cut this at an angled rotation. I could go into planes. I could do dynamic. Just put this at the origin. First of all, I'm going to turn off 2D. There. Let's rotate. Oh, I don't want that rotation. I want this rotation, this plane. So I've got my increment set to 10 degrees. I think the default is 5 on this little scale. You'll notice as I move my cursor, I can change the angle. I'm basically locked on the x-axis and I'm rotating y and z. If I want to change my increment, I can move my cursor on the gnomon. There we go. So if I'm just on the gnomon and I right click, it has to have a piece that's highlighted. So that's where I can change my activate angular snap. So I can set it back to 5 degrees or 2 degrees or whatever I want. I can change the size of the gnomon. So you notice you can adjust that out. You can change the size of the plane visualization. You can change the opacity if you want, so you can make it darker or lighter. And you can change the size of the ruler. I like a larger gnomon. I think it's easier to interact with, so I tend to go to the upper end of the scale. Okay, so that's the properties of setting the gnomon display. Oh, let's see if we're crashing it. We might be crashing it. Stop sharing for a second. Oh, it worked. Ha. All right, well, I'm not one to gamble too far, so I'm going to save real quick, and I'm going to turn the sharing back on. So we got it saved, okay, and let me here, the Mastercam. You guys can see it okay, yes?
Yes, I can see. Yeah.
Cool. Okay, cool. All right. One of the things I usually will do in a situation like this, especially if I'm not using them, I'm going to put these on a different level. And force the visibility off. Okay, so getting back into doing a plane real quick, I'm going to go dynamic. The thing I was going to show, I'm going to hit O to lock it to the origin. Now I want to rotate it. Let's say I want to rotate it 3.5 degrees. Well, as I start rotating, you'll notice that as I'm on the tick marks, it's going to lock to an angle increment. As soon as I drag it off of there, there's a display for an actual angle. If I just start typing in a number, I'm going to type in 3.5. So I'll type in 3.5 degrees on my number pad. I'm going to hit enter once to accept the number, and then I'm going to hit enter again to accept the value. So I'm going to do that, and then I'm also going to tilt it, say this way, and let's go 12.241 degrees. So this is a compound angled plane. Let's call it angled plane 1. And I'm going to make sure the top is my WCS and my tool and construction plane is set to that tool plane. And then in my toolpath, I'm going to set this back to plane. And we're going to use a plane. So you do have to kind of create it first. And this is going to control my tool axis. So all of these vectors should basically be the same, right? We're just coming in at a locked angle, fixed angle plane that's controlled by a plane. So this is a perfect example of where filter would probably be good. So you can see I'm going to drop in with all these vectors, and I just need boom, 2, 3, 4 in the corner, and I'm good. So code-wise, this should create a small amount of G-code. A little bit for the rotation areas, but otherwise really not too much. So this is all entry, basically. That's all entry motion. There's like our four corners plus the overlap, and that's like the exit motion. So, and that's the result of just locking it to a plane. So what else do we have? For tool axis control. From point and to point. So from point is generally a point that's going to be up above what you're cutting. And so if I go into the from point, now it's telling me to select a point. Well, I don't have anything directly above there that I know where it is. How could I just type in a point if I wanted to? I know my rectangle is roughly, I don't know, in the kind of 10 by 10 size frame. I only know that because I'm using like a 1/2 inch end mill to cut it. So what if I just wanted to create a point on the fly? It's telling me to select a point. If I hit the space bar on the keyboard, this is what's known as comma delimited data entry. So I can literally type in an X, Y, and Z point. So I'm going to type in 5, 5, 10. Enter. So I can actually generate a point on the fly. Now looking at where it put it, I can see 5, 5, 10 is not really where I want to go. So I'm going to hit clear. And let's do a select again. And let's try space bar 2.5, 2.5, 10. See if it's actually creating it on the fly or not. Oh, hold on. 2.5, 2.5, 10. There it is. That's better. So I'm going to let it be from that point. I'm going to select OK. And generally speaking, I would have created that ahead of time anyway. Oh, is it locked now? Man, I might have to have the point exist beforehand. And it may be a little funky because I've just been changing parameter after parameter in the toolpath. So here's a good lesson. I've been going into the same path and changing a bunch of stuff over and over again. So I'm going to back out of the toolpath. I'm going to save my part file, make sure I've saved it kind of a couple times, make sure it's really truly saved. I'm going to click on File, File menu. There's this option here for Repair File. So it's used to be called RAM Saver. In fact, you notice the icon still shows the little RAM Saver icon from when it was labeled RAM Saver. So I'm going to press Repair File and it's going to tell me what it's going to do. If possible, the database will be compacted and the display list will be rebuilt. Do you also want to delete duplicate entities? So you can say yes or no. I recommend most of the time saying no, unless you're kind of working on a fresh file and you haven't been doing a lot of stuff to it where you're moving stuff around or separating. And here's what I mean. When I'm programming 5-axis part, quite often I'm starting with a model, but I'm creating geometry that I need for specific areas during my programming process. And so often I have copies of the same geometry that are on different levels. because I'm using them differently in different processes. And if I say yes, there's a potential here with delete duplicates that I might accidentally try to delete geometry that's tied to a toolpath. Or it's going to run and it's going to search through it and it's going to say, oh, here's a bunch of geometry that's not tied to a toolpath, but oh, look, Colin's got geometry on a different level that is tied to a toolpath. So, hey, I'm just going to delete the geometry that's not tied to the toolpath automatically. And so you might have some geometry for visualization or something on a different level, and all of a sudden it just blew away some of that. So, do you want to also delete duplicate entities? If you say no, it is still going to run repair file. It's just not also going to execute delete duplicates. So I'm going to say no. Wants to know, hey, if I have arcs that could be on one of the standard planes, top, front, right, do you also want to combine them onto the same thing? I generally say yes, but just know that if you have some arcs that are in a toolpath, they've already been selected as part of the chain. This can potentially break some of your chaining associations if you do it. I think it's generally a great thing to be done, but it's just something you want to be careful of. Yes, I'm going to do it. It does tell me in this case, 0 arcs moved to a new view. Okay. Now it tells me the good stuff. Database has decreased by almost 200,000 bytes. The Mastercam file, blah, 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 for this class has changed. Do you want to save it? Yes. So that went through and it compacted the database. It cleaned up a bunch of stuff, and it also triggered a file save as, which means you're completely writing the file to disk instead of only writing the incremental changes that have been made since the last time you saved it. Otherwise known as, when does save not really save? Well, when that saving operation is executed with just the save button, you're only really saving the incremental changes. So I like to do a save as, and as part of that, I just run file repair and it does it for me. So back to the tool axis control, I'm going to hit clear under the plane. Oh, it didn't do it. Okay, that's fine. Let's do from point. I'm going to hit select. I'm going to select that point. I'm going to hit OK. And instead of my tool axis control being tied to a plane, it is now tied to a point. Oh. Let's try this again. You know what? In fact, let's just create a new toolpath here. Mill toolpaths, multi-axis curve. We use this 1/2-inch ball end mill. Curve. Oh, let's reverse that direction. Radial offset's 1/4 inch. Tool axis control is going to be from point. So there is no physical point yet. So that's a bug. So what I'm going to do, I want to save that. Now I'm going to go into the top view. I'm going to set my 2D 3D switch to 2D. I'm going to set my construction depth to 10 inches. And I'm going to go wireframe, point by position. I'm going to highlight the corner of the box until I get the little green temporary point. I'm going to highlight the opposite corner of the box, and then I should get this temporary midpoint. And because I'm already set to 2D and my Z depth is set to 2 inches, it physically created the point. Now I'm also going to translate copy this, and I'm going to go negative 5 inches. And I'm going to do that 4 times. So now I've got a series of points that I can use or shift to if I need them. Sec, guys. So curve 5-axis, I'm going to go into the parameters. We've got our cut pattern selected. Yep, cut pattern's in. Okay, the chain's in. Tool axis control from a point. I'm going to select that upper 10-inch point. Collision control, we're going to do comp to surface. Up to this flat surface here. And everything else default. So now what I'm getting with my tool axis control set to from a point, the vector that passes through the center of my tool is always aligned so that as I march along the tool path, I'm always keeping that center point, and I'm just manually kind of moving it as I hold down S on the keyboard, but I'm always keeping that aligned to that center point, the center of that tool. Now, I would want to fix some things on this path for certain. For example, entry-exit is kind of poorly defined, right? Let's do a closed loop overlap, 50%. Much better. We've at least got some entry-exit. Okay. Well, how about roughing and finishing? So if I go to roughing, this gives us the option to do contouring cuts. So we can do depth cuts and or multi-passes. So you can do them with or without each other or combined together. If they are combined together, you can choose your depth cut order. Do you want to go by depth or by contour? So do you want to process, if you're processing multiple chains, do you want to process all the depths in one chain first before going to the next? Or do you want to alternate with layers, with depth layers? So typically you're probably going to do one or the other, or maybe a limited set of both, but you're probably either going to be stepping over and taking multiple step overs or stepping down. In this case, we're just going to do step overs. So I'm going to say I want 2 rough passes of say 80 thousandths each, and I want 1 finish pass, and let's make that 20 thousandths. I can choose whether I want to keep tool down or not. So, and if I'm roughing with depth cuts, whether I want to machine finish passes at all depths or only at the final depth. But let's see what we got here with no other changes. I'm just going to do multi-passes, 2 rough passes, 1 finish cut. Okay, so if I backplot this, first cut, coming around, tracing on the floor. Now what happened here? If I back up, let's kind of walk through this. I'm going to hide. I'm going to do this. I'm going to back up till just after here, and I'm going to turn on restricted drawing. And that hides the moves that have already occurred. So I'm just going to filter those out visually. And let's look at what's happened. So we've already done our entry move. Now we're coming along, we're finishing up our first roughing cut. And what happens when we get to the start point? What happened is we're not doing an entry exit on every cut. So it gets around to that start point again, and now it just moves vector to vector, and it kind of gouges in a little bit as it finds the start point. And it also doesn't help that we've got going just so it's not causing some confusion. I'm just going to turn off closed loop overlap because I want you to see what the normal behavior here is. So what happens is we enter, because we have entry turned on. We do our first rough cut. It should be coming around. We get to that entry point, and we just plunge into the start of the next cut. It just moves over right against the sidewall, no entry. Same thing for the finish, just boom, bumps right in. And then it executes its finish cut, finish, comes around. And I'm just, to visualize this, I'm just holding down the S key. And then we exit, and then we retract. And that's because under the curve, under the entry exit in the curve 5-axis, you don't have always use turned on. So always use tells us on every cut when we're doing depth cuts or multi-passes, we want to force this entry exit. Now, I would also recommend if you're going to do that you minimize the amount of time you spend in the entry exit, so you make your entry and exit amount as small as you can safely tolerate. Otherwise, it just means you've got kind of quite a few retracts and repositions. So this, there we go. And because we are doing a plunge, one of the things you'll notice is it's doing some weird stuff with how it has to compensate to that bottom surface. But it is doing entry exit. Now, we may wish to go back in here. We may wish to get rid of the height. It's a lot smoother. So that would be an option there. Maybe use a lesser value for the height, 2 thou or something. So it enters, cuts around all the way to the first. Oop. So then it goes out on its exit, and let's see what happens here. So it retracts, repositions, plunges down, goes in with the final vector move at the plunge feed rate, and then it starts executing at 50% speed the entry. Then we go around at the regular speed for the cut. It goes here, and then it starts slowing down. So technically, we're slowing down on the exits. Is that what we want to do? Maybe. Depends on the, the kind of finish that we may be worried about leaving. I'd say let's go faster on the exit. We're getting out of there. So, hey, we're all done cutting. The cutting force should be lessening as we kind of come to that final piece of overlap. Now let's speed up on that exit curve so that we're actually making some time. And the other thing that we could potentially do under here, because we're using clearance only at the start and the end, let's do 100 thou for the retract and 100 thou for the feed plane. And provided, that this motion doesn't cause us to bump anything, which it shouldn't, because it's executed, with plenty of lead in. Now we can go and cut around. Go. So it finishes up on its cut. Comes back around, repositions, moves over, drops down, enters in for the next cut, up with a finish cut. So that always use, if you always want it to use the entry and exit, I would enable that, because otherwise, if you don't, you're only going to get the first entry and the last exit. So again, that is the always use little checkbox. And now we just get one entry and it just steps over, and then it does its final exit. Now, I'm going to go back in the parameters here. A couple to finish up on, just because I want to get through this. 2 point means that point is, generally speaking, below the geometry, and you're always pointing the tool at a single point. It's funky. Yeah, I don't know if it just lost everything there. Yeah. I don't think it really likes changing the methods too much. Let's do that. Let's do the radial offset. Let's do 1 inch just to see what it does here. 2 point. Let's go from point. We're going to deselect. I'm going to try all of these. Deselect. Surface. Deselect. No drivable surface. Okay. And it's not letting us remove it. From point. Let's try clearing it. Let's go 2 point. Clear it. Hit apply. Missing tool axis. 2 point. Select it now. Yes. Let's look at the top view. Okay, it should be right in the middle. It's the 2 point. There it goes. Now it's generating. Okay, so exactly the same path, but we just changed with a from point to a 2 point. So now it's rotating where it's always trying to keep the center line of that tool focused at whatever tool. And because I chose this point, which is only 5 inches deep instead of 10 inches deep, we get a more extreme angle. Whereas if I grab the same 2 point but deeper, should generate. Ooh, man, it really doesn't like changing the from and 2 points. That's just like, nope. Okay, but all we should have to do here, just make sure our cut pattern is properly selected. Oh man, it doesn't like that one.
I've seen some really weird stuff with this. Maybe 2024, but even the projection tends to lose its mind if you have surface versus plane.
Yeah.
It's strange stuff happening with this. Have you tried resetting all defaults? Or resetting to defaults?
I mean, I could do that. I think really because we generated it and it worked, and then we tried to change it. I'm just going to create it again. cut pattern, 3D curve, boom, tool axis control, from point, 2 point, come on, 2 point, point there, collision control, comp to a surface, 0 degrees, we got roughing, we got 2 multi-passes at 0.08, we got 1 and 2. Yeah, there's something weird about going in there and changing it, and then like changing it again. And now, granted, I don't have a. Ooh, let's fix the entry exits. Yeah, that's all weird. Okay, so use transfer. Okay, there we go. There's the from point example. The last example is chain, as I'm sure you can probably guess. It allows you to use a chain kind of up above the toolpath or below the toolpath to constrain where it can go. Can be pretty useful. Quick example. There's one on here that we used a chain on. Okay, from point. Anyway, let's go. Now here's a good example. If I change my method here, we delete the point, and I change this to a chain, and I go to click on my chain, you'll notice that the start of my toolpath is here. If I drew this in the top view, which I just did, where do you think the start point of this arc is going to be? Anyone? It always faces in the X positive direction. So if I get out of this toolpath creation and I analyze this arc, what you'll see is the start and the end point is over here on the right-hand side. Okay, so I got 2 ways I can fix this because I really want that start point aligned for where the start of the chain is. Otherwise, it's going to get funky real fast. So I can change the start and the end point angles here. 720, no, 540. Okay, so I can change the start and the end angles, or I can take this and I can rotate it. So if it was over here, if my start point was here, I could rotate it 180 degrees, and I could change my start point location, which is now facing the right direction. So I'm going to save that. We're going to run repair file. Did find something. We'll go ahead and save that. Let's see. Let's see. So, go back. Gonna go to my parameters. We're going to change this to chain. Go to select the chain. We'll select it there. Start point's going to align to our entry exit. Oh, and we'll say chain options. We'll say closest point on the chain. And now the center line of the tool should be aligned to that chain. Let me change one thing here. Step along the whole chain. Leave that. Change it. Yeah, that should make it a little smoother. And this is going to apply to the tool, not necessarily to the tool holder. So as it's in there, it's trying to stay aligned to that chain for the cuts. Now, would I use a chain method here in this instance? No, I wouldn't. I would probably pick one of the others. But this can be a pretty nice option for you, especially like if you're trying to get in between a certain area and there's some like tilt to it. You can draw out some pretty cool chains to say, all right, I always want my tool center line to follow the center line of that chain as we step through here. Okay. So we gave kind of a quick review to multiple different types of tool axis control methods. Let's go back to the lines for a minute. Okay. So one thing I do want to point out, and I think it'll be easier if we turn off the roughing. So we're just looking at a single pass here. So I'll turn off the multi-passes. We get a single pass. What happens between here and the next 5-10 moves? Anybody? What's going to happen out of the machine? In Mastercam, what we're going to see, I'm going to turn off the tool. Well, look at this in the front. So we're looking straight on. And I'll press S. And what are we looking at? What do we see here? What are each one of these? It's a vector that represents a tool position. So, in a relatively short number of moves, we've got quite a bit of rotation. And because each one of these is only one move in the NCI, what we can end up with in the code, just post it.
That B-axis rotation.
Yep. And what we're going to see after we do our entry move, blah, blah, blah. How much is it changing? Roughly 3 degrees. What's causing that rotation? Sure, we're transitioning between these two vector lines, but we're doing it over kind of the amount of step we've told it to take. And so what's kicking in right here between those positions, between those two vectors, is this. There's a control called angle increment, which says, hey, if the angle of the tool changes more than this amount of rotation, give me another vector. If I turn that off, just like boom, 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 you get all that rotation in about 3 moves. So we go look at the code. 3, 7, 20. Boom. You know, I mean, will it work? Maybe. Only way to know really is to run it, but you're much less likely to get kind of the results you want if you're not paying attention to how quickly these vectors transition. So my rule of, shouldn't say rule of thumb anymore, I guess. It's, I don't know, discriminatory or something. I still don't know how, but anyway. Because we're not using it in the original context, but I digress. So, okay. So, tool axis control, angle increment, 1 degree, half a degree, 2/10 of a degree, 1/10 of a degree. Those are kind of the common numbers that I use depending on, am I getting the output that I expect? So let's start with a 1 degree. That looks a lot better. And what do I mean by better? What am I judging this on? I know there's going to be a rotation. How even and smooth is the distance between these angled vectors? Okay, because you'll notice as I add these extra vectors, what happens here? The distance in between, let me unshade it, the distance in between these vector positions gets a little smaller. So what that's going to result in, let me just, I'm not using this and it keeps warning me. So yeah, I'm going to get rid of that and repost this. So now, about a degree. Much smoother rotation where all the rotation is occurring, even at some of the other areas where we were only going from like 25 to 26 to 27. You notice there's only a quarter degree, 2/10 of a degree between some of these moves, but because it's rotating and it's stepping along, that's why we're getting those extra outputs. And even with the increase in the number of angles that we're doing, we may be able to combine a couple of settings. So cut pattern, I kind of alluded to this a little bit. Cut tolerance is how accurately are we going to follow the actual shape we're cutting. Well, in this case, it's like some straight lines. I mean, it's about as simple and easy as you can possibly get. So 1/10 or 1/1000 tolerance is probably okay. But one of the things we can do is we can set a minimum distance between the points. And with that turned off, we can also set a maximum step. So that's one of the things that's killing us here, right? We're getting a vector 100 every 100 thousandths, whether we like it or not. So if I set this to like 3 inches for the maximum step, that should take care of quite a bit of our issues. Because now it's like, oh man, well, hey, if the vector hasn't changed, I'm going to output one every 3 inches just because. But hey, man, if the vector doesn't change, I don't need to change it. But look what happens where the rotation is. So this is kind of the best of both worlds. And I did a horrible thing, Jeff, where we were talking about this, about the filtering, and then I went off and talked about something else. And now I'm kind of coming back full circle. But that's what I was going to get to, is my preference is to, instead of using filtering, is to use the maximum step here and play with this in combination with the angle increment on the rotation, because I could go, hey man, I want one every quarter degrees. I want a lot of vectors because I want it really smooth when I rotate. Well, as that changes, one too many changes and I blew it up. 10 is too big. So you don't want a maximum step size under the cut pattern here that is longer than the actual geometry you're driving. I'm going to go back to 3. 3 was good. I could try 5. I could try sneaking up on it. And I can always add filtering if I really am like, hey, I don't want this extra vector here, man. But what I don't want is the filtering to remove all this nice rotation vectors we've got in the corners where it actually is rotating. So even with the maximum step, I'm going to go to filter, and let's turn that on too. And let's say okay. But see what the filter does for me? The filter's wiping out my extra vector moves that were giving me all that nice rotation. So there are some cases where, yeah, I could probably mess with this. I could probably mess with the look ahead, but really this, the curve following method, is really giving me exactly what I want. So it's using a cut tolerance instead of a physical distance. And I'm just saying, hey, my maximum step here is fairly big. Maybe that's too big. Maybe I want 1 inch. And I know that even with 1 inch, I'm going to get a few extra vectors. But what happens when I get these extra vectors and there's no rotation? What am I going to see in my G code? The thing every machinist, and myself included, complains about. Like, hey, what the heck is this, man? What are you doing, Mr. Programmer? You just got X, and then you got another X, and then you got another X, and then you got another X, and then you know what I mean? So that's where it's like you want to play around with these input parameters to try to get perfect, clean code. And it's always an attempt. It's never a solid guarantee. I don't care how long you've been doing this. I can tell you that's one of my personal experiences over the years is, you play with it and you mess with it and you learn new things, and somebody comes along and goes, oh, well, why don't you just do it like this? This is how I do it. And then you slap yourself in the forehead. You're like, man, I've been doing it the hard way, like forever. What the heck? How come I didn't know about that? And, that's part of the reason we're going through this as an exercise, is to talk about some of the things that that you're not going to find in a book on 5-axis. There's a lot of book on 5-axis will be like, yep, here's the toolpaths, use this file, click here, type in this number, type in that number, check this box, boom, you got a 5-axis path. Aren't you great? Don't you feel trained? So, the idea of these sessions is to give you, some time to interact, to ask questions. And I know I just kind of was like, blah, like puking a bunch of information at you, and it was a little all over the place. But those are some of the kind of basic introductory things that I like to talk about when I'm teaching 5-axis, right? Start with the basics. If you don't understand the basics, jumping into the advanced stuff right out the gate is kind of like, uh, there are better ways to spend our time. So, if you guys have examples of stuff you want to look at, if you have questions about any of the stuff we've covered today or in general, or if you just want to think about it and ruminate for a little bit and then come back with questions later, my intent is I would love to get another training session in this week. We'll have to, I see your hand, Brock, one sec, and we'll see if we have time this week, but definitely next week. I've got some time as well. So I'm going to look at the calendars and see when we can get in there. Brock, go ahead.
Right. Well, I ran into one problem with Curve 5-axis recently. I pasted it in the chat. Hopefully you can see that image. There was a problem that I narrowed down to the projection, and I wasn't able to reproduce it. Wondering if y'all have seen this before. I ended up having to reset the tool path parameters and then change the projection plane. Of course, you have to reset all the options and parameters within the tool path. And that fixed this problem. But I assume that this probably related to a problem with the lines and arcs not touching the surface or being on the positive side of the surface.
You guys see this? The times when I've had a Curve 5-axis skip motion like that, it was typically related and there are only certain toolpath types that have that kind of minimum projection distance, surface tool axis control being one of them. So keep in mind you can always create a flat rectangle on a plane and just make it a surface and have it be, below the surfaces you're driving to get that projection normal functionality. The other thing to check sometimes is just if you're driving off the edges of a solid, you should be fine. If you know you've got lines, you should be okay. Splines sometimes have a weird mathematical definition that the curve is there, but it wasn't created. It was created in a different plane or coordinate system, and there's some weird translation stuff going on. But yeah, curve is funky. One of the kind of dirty secrets about Mastercam, there's a lot of technology that's like a plug-in to Mastercam. So there, for example, if you look under this little gallery, you'll see an example of it. Swarf milling versus swarf. And you say, why are there two of these? Curve 5-axis multi-surface and swarf, and maybe flow. Those are some of the original 5-axis toolpath technology that Mastercam either built or licensed 20 years ago. Starting in like 2007 or 2006, starting around the X4 timeframe, CNC Software started licensing technology from ModuleWorks. And so swarf milling, unified deburr, pocketing, rotary advanced, triangular mesh, 3+2, maybe rotary, maybe not. I'd have to look. Blade Expert and Port Expert, those are all technology that's developed by a company called ModuleWorks and licensed by CNC Software. So those toolpaths are integrated into Mastercam, and the newer stuff from ModuleWorks is a lot better than the older stuff. Let me just put it that way. And I think, Brock, you've seen a little bit of that I've been going through and taking the same toolpath and just changing the tool axis control method, and it like freaks out, right? But then I delete that path and I start over and I create a new version of the path, and all of a sudden it's working again. So sometimes it takes multiple attempts, I always make sure this is what I call a run out surface, right? Where I've got the geometry I'm trying to drive. I don't want my surface geometry exactly on the edge of the geometry I'm driving with curve. I want it to go way past. I don't want my normal surface to be right on the edge there. I want it to go way past. And I do that to make sure that however the geometry is being projected down, I know that the projection is going to lay there, because the dirty secret too here is that the projection is done after the offset. So like if I'm offsetting to the outside here, I could have a place where the vector that's getting projected goes way beyond the extents of the surface unless I do this, where I physically extend or build the surfaces so that they're not necessarily wider than the piece that I'm driving. Well, hey guys, we've been at this for a while. I hope it's been useful. We just barely broke the surface, but I want to go through and cover. I mean, even with Curve 5-axis, there's probably 10 more things that we should cover just to get a good understanding and feeling with Curve 5-axis. And then there's Swarf and Unified and Deburr and all that stuff. So there's a whole lot more to get into. But I also kind of want to take the approach of trying to do it in more, bite-sized chunks. So it's not just, I would love to, don't get me wrong, I would love to get us all in a room for a week together and spend a whole time, just doing nothing but Mastercam and 5-axis. I think this is probably the best that we can do, at least currently, with getting everybody together, especially on different teams. So, send me questions, send me example files or parts or stuff you want me to take a look at. When you run into stuff, write it down, save a copy of the file if you can. And hey, it's everybody starts somewhere, and I hope this is useful.
Yeah. Any chance we can start up Mastercam users group for teams or something like that, so we can put together the conversations?
Yeah, go ahead.
That's a good idea.
Yeah, let's do it. Someone take the lead. The answer is
right.
Any of you can do that except me. So do it. Take charge of it. I'm going to go ahead and stop the recording.